In order to talk about horizontal and vertical lines, let's look at a line that's not horizontal or vertical. So click them all the way closed. Focus up here. We'll get this. We'll get through this short and quick, intense, and then you can get to work on this stuff. So what if we had a line like this blue one right here? Say I graphed this line and I told you to write the equation of the line down. Does it make sense? Like we would want to know if I want to put it in mx plus b form, I'm just filling in the values for m and b, right? Make sense? So we'd look at b as the y-intercept. Everybody agree it's at -1? So that's the value we're plugging in for b. The value for m, if we make a slope triangle, I'm going to rise by 4 and run by 1, and so I get a value of 4. And I come up with an equation for that line. Okay, now let's think what that equation does. We haven't really talked about it in this context yet, but it does a lot. Fundamentally, it's connecting the x's and the y's, the inputs and the outputs, right? What I mean by that is, like, what if I were to start with an x value of 1, and I said, what's the y value that goes with that? How would you find that? What would you do?
If it was on a graph, you'd find out.
If it was on a graph, it'd be easy to do, right? If it's on a graph, when x is 1, you could just go over to when x is 1, we can see that y is 3, and that's the answer. But what if it's not? How would you do it with the equation? If I know that here's the equation of the line, and the x value is 1, how could I find the y value? Plug in a number for x, right? That's the job of the equation, is to connect the x's and the y's with some relationship. This is the relationship right here, this equation. So if x is 1, I would just plug 1 in for x and figure out what y is, solve for y, right? If I plug 1 in for x, I'm going to get y equals 4 times 1 minus 1. Well, that's just 4 minus 1, which is 3, right? And so I'm going to get back the y value 3. And sure enough, that corresponds to the point on the line, doesn't it, right? If I were to, let's say we're going to do this a little differently. Let's say we started with something like y equals 7. I said, okay, y equals 7. Now, what's x going to be? What would I do? Plug in y equals 7, right? We're just going to go to our original equation, and we're going to plug in y equals 7 and solve for x. I get 7 equals 4x minus 1, so isolate the x. Add 1 to both sides and divide by 4, and I get x equals 2. So if I start with y equals 7, the equation gives me the x value. It works both ways, doesn't it? It connects the x's and the y's. Okay, the point I want to make here is, would you agree that if I'm going to make that line, the graph of that line, the x's and the y's are both essential parts of that equation, aren't they? Right? Because they're both changing at the same time. And the way they change is predicted by that equation. And we'll come back to that idea again very soon. So it's actually very, yes?
Why is it minus?
Because b is, good question, because b is -1. Okay, so we're just plugging in a value for -1. So really, it's technically speaking, it's 4x plus -1, but what's our simple way of saying plus -1? -1, yeah. Okay? So, and notice one other thing. Notice that if I just pick some random point that's not on the line, right? There's a point with coordinates 4, 1 that's clearly not on the line. Should I expect if I plug those x and y values into this equation that the equation's going to be true? No, because that's not obeying the relationship between x and y that this equation has, right? And if I plug it in, I'd see something like, well, if I plug 4 in, I'd get 4 times 4. If I plug 4 in for x, I'd get 4 times 4 is 16 minus 1. I'd get y equals 15. Well, that's not what I have here, is it? Right? If I plug 1 in for y and 4 in for x, it's not a true statement. Shouldn't be, though. It's not on the line. Okay, now let's look at a different situation, though. What about lines like this? Let's take a vertical line and a horizontal line, and let's come up with equations for those. Anybody remember what this is? It's a line, but what's the equation of that? Say it again. Y, okay, that's true. Y could be anything, couldn't it? Y could be anything, and that's actually an important part of the equation of that line is very simple. The equation of the line is x equals -3. But how come? How come no y shows up in that equation? Do you see a difference here? If I pick any point on this vertical line, does it matter what the x value is? What's the y always going to be? The slope is undefined. But if I pick any point on the line, I'll pick a couple here. There's one, there's another one, right? Any of those points on the line, does it matter what the x value is? What's the y value always going to be? The y coordinate, I got it backwards, sorry. Let me say that again. Rewind your brains for about 15 seconds. If I pick any points on this line, it doesn't matter what the y value is, right? That's what Alyssa was saying. It doesn't matter what the y value is. What's the x value always going to be? -3, right? There's no connection between x and y. We don't need to know what y is because x is always the same thing, right? That's different than this line we were just looking at over here. This was different. Depending on the x or y value we pick, we have to use the equation to figure out the other one, right? They are connected by that equation, but in this case, they're not. So we don't even need to include the y in our equation because who cares? Y could be any real number. X is always going to be -3, right? For a simple way to remember that, if you've got a vertical line or a horizontal line, just a really quick, easy way to remember how to write the equation, always ask yourself if it's vertical or horizontal, which axis does it cut through? X or Y? X. Cuts through the x-axis. Where does it cut through? At the name of the equation. X equals -3, right? Because the x values are all going to be the same, so you might as well pick the easiest one, which is the x-intercept, to define it, right? They're all going to be the same, and you can see by the x-intercept that x equals -3, right? So there's an easy way to remember how to write the equation of the line. So Kim, what do you think? Based on that logic, what do you think the equation of this line is going to be?
Y equals 1.
Yeah, y equals 1, right? Okay, because it cuts through the y-axis at 1, and how come? Same logic, right? If I pick random points on this line, it doesn't matter what x is. It could be anything. It could be a trillion. What's y going to be? 1. The y is unconnected from the x, right? That's if you really stop and think about that for a second. To me, that's one of the amazing things that math does. It's so self-consistent. Things just work out exactly the way they have to. Who knows why? They just do. It's just the way math is. If you don't have a variable in an equation, it's not there for a reason. It's not there because it's independent of that variable. It doesn't have any impact on the graph, right? Okay, so now moving forward a little bit. Parallel and perpendicular lines. See what you remember from Algebra 1. Slopes of parallel lines would have to be what? What would they have to be? The same. They'd have to be equal, wouldn't they? That one probably makes a little more sense, right? I mean, that one's not so hard to see. The other one, perpendicular lines, this is one that's harder. It's harder to prove this one to yourself. This is one you just sort of have to remember. The slopes of perpendicular lines. Now, let's think about this. What can you tell me about the signs of the slopes? Let's say this is my original line. And what does perpendicular mean, by the way? I should have probably refreshed our memories on that. They meet at what kinds of angles? 90 right angles, 90-degree angles. So if this is my original line, positive or negative slope? Positive. If I take a perpendicular line, what's the sign of the slope got to be? It's got to be negative. So one thing that has to happen is when we have perpendicular lines, their slopes have to be opposites. If one's negative, the other one's positive, and vice versa, right? The other part is a little trickier to remember. So we know that the slopes of perpendicular lines are opposite. But what else goes with it? Say it again. Reciprocals. There it is. So if we have the slope of a line and we want to find the slope of a perpendicular line to that line, we've got to change the sign and flip the fraction. Both of those things. Okay? So then here's my question. Now, and let's be really smart about this. Let's make this as easy as possible. We've got these two lines here. We've got a red line, we'll say, and we've got a blue line. Okay? And I want to know if those lines are parallel or perpendicular or neither. Well, what is the only thing I need to know about those lines to determine if they're parallel or perpendicular or neither? Slope. Right, the only thing I need is the slope. Now to get there, I might use the same technique that we used yesterday. That would work, the slope-intercept, right? If we go back to, let's look at the last example we did yesterday. How about down here, number 9? We wanted to come up with a graph of this equation. We wanted to graph that line. So what are we going to do? If we want to come up with a graph of that equation, what are we going to do? We wanted to put it in slope-intercept form. We're going to have, starting Friday, we're going to have another way of doing that without having to write it in slope-intercept form first, right? But for now, that's the only show in town. So we got to put it in slope-intercept form, which we did. What does that mean? Putting it in slope-intercept form, we just said, was isolating y and simplifying, right? So we decided the steps to isolate y. First, we subtract x, good. We want to put the x term first. Then we divide by 3, okay? And so we get y equals, and I'm going to divide each term separately by 3. So I get negative x over 3, but we recognize that we want to have the fraction being multiplied by x. So we got a negative 1/3 x minus 5. And we decided then that the y-intercept must be negative 5, and the slope must be negative 1/3. Okay, if I'm just trying to find the slope, I didn't even need to mess with that other stuff, did I? I just needed to know if I isolate y, what's being multiplied by x. That's always the slope, right? Because if I isolate y, I'm putting it in slope-intercept form, okay? So let's apply that same thinking here to the red equation. What are the 2 steps to isolate y? Add 8x. First step is add 8x. Oops. Good, okay, so then that's going to give us, it cancels the 8x's off the left side, and I get 8y equals 8x. Last step? Divide by 8. Okay, so we divide by 8. And we end up getting the equation y equals x. Okay, so that, we isolated y, so it has to be in slope-intercept form, right? What's the slope?
1 over 1.
Okay, it's what's being multiplied by x. So it's 1, isn't it? Right? So we know, because there's an invisible 1 there, if a number that's being multiplied doesn't show up, what is it? It's got to be a 1, right? So we know that the slope equals 1. Not that we care about it for this problem we're doing now, but what is the y-intercept? 0. If a number that's being added doesn't show up, it's got to be 0, right? And all we're doing is comparing this to y equals mx plus b form to see what the values are, right? So m is 1 and b is 0. All we care about, though, in this problem is that m is 1, right? What about the blue line? What do I have to do to get y by itself there? I'm going to rewrite that one. So what do you say again? Subtract x. Good, so we end up with y on the left side. I'm going to put the x term first, right? So we'll get negative x, that's a negative y, isn't it? Negative x plus 4. Last step. Say it again. Divide, or it's a little easier to multiply. I'll show you why. It's just easier to show, because look, we can do it this way. If I'm multiplying, I can just put brackets around the whole thing and put a negative 1 out front. I don't even need the negative 1. I can just put a negative out front. And when I distribute that, what am I going to get? Y. Okay. And so, once again, I don't really care about the y-intercept, but what's the slope? So what can you tell me about those 2 lines? They're parallel, because the slopes are both equal to 1. They're equal. Okay? How about down here? Now this is a little bit easier, because this one's already set up for you. If they're already in slope-intercept form, so what's the slope of the first line?
5 over 1.
What's the slope of the second line? And 5 as a fraction is just 5 over 1. Well, what do you know? They're opposite reciprocals. One's positive, one's negative, and they're the flip of each other, right? So those have to be perpendicular. There we go. So they have to be perpendicular, don't they? Okay? So on your new e-ticket, just do problems, what are they?
The box.
The box ones, 11 and 12. 11 and 12, I'm gonna make the rounds.
Why did we do the hardest stuff? Just make it easier on them?
You know, it's just kind of the pattern in algebra too. That stuff's supposed to be reviewed, but I don't think it was that much review, was it?
No, like.
It's good or good not.
Yeah.
So, last part. X and Y intercepts. Okay. X and Y intercepts are easy to find. Now you tell me real quick, what is the value of the Y-intercept in this graph? 4, right? Because it's right there, isn't it? Okay. So the Y-intercept is 4. If I write that as an ordered pair, what is it?
0.
0, 4. Okay, now there's the important thing. It's a 0, 4. How about the X-intercept? What's that? Negative 3. Is negative 3, which means its coordinates are what? Negative 3, 0. The zeros are important there, right? Wouldn't you agree that every X-intercept, every possible X-intercept, it's on the X-axis, so the Y-coordinate is 0, right? Every Y-intercept has to be on the Y-axis, and so its X-coordinate is 0, right? So what if I'm going to skip this part just for now. We don't need that. So what if we want to do something like we're given an equation like this, and I want to find the X-intercept. What has to be true at the X-intercept? Y is 0, right, at the X-intercept. If I want to find the Y-intercept, what's true? The X is 0, right? So if I want to find, so like if I'm looking for, what did I do purple? Okay, I'm going to do the Y-intercept first. Okay, so if I want to do the Y-intercept, it's going to be the ordered pair where I know that X is going to be 0, right? And so if X is 0, what do I get? If X is 0, I'm going to plug a 0 in for X, and I'm going to get Y equals negative 2 times 0, which is 0, plus 5. So Y is just equal to 5, isn't it? See my point? Okay, if I want to find the X-intercept, it's going to be the ordered pair where Y is 0, right? And we've got to find X. So we go up to this equation up here, and we'll just plug in 0 for Y. And we solve for X. What are the 2 steps to solve for X? Subtract 5. So I get negative 5 equals negative 2X. Divide by negative 2. And so I get X equals negative 5 over negative 2. That's just 5/2, right? Easy. I want to find the X-intercept. I said Y equal to 0 and solve. I want to find the Y-intercept. I said X equal to 0 and solve. So how many points do we need to graph a line? 2. So one thing we could do is we could just find the intercepts because they're so easy to find and connect and extend, right? So let's look at an example. Like what about number 2 here? If I want to find the Y-intercept, I'm going to let X equal 0. Well, if X equals 0, I don't have to even do any math. If X is 0, what's going to happen to negative 6/5 times X? It goes away. I can just cover that term up and solve for Y, and I get Y equals 2, right? Easy. So we get the point the Y-intercept is at 2. What if I want to find the X-intercept? If I want to find the X-intercept, I'm going to set Y equal to 0 and solve for X, right? So what's that give us if we do that? We're going to get 0 equals negative 6/5 X plus 2. What are the 2 steps to get the X by itself? Subtract 2. Okay, so I'm gonna get a negative 2 equals negative 6/5 x. How do I undo multiplying by negative 6/5?
Multiply 5 on each side.
Multiply. In fact, I can do it without even having to just clear the fractions. I can do it in one step. Like normally, think what we do normally. So if x is being multiplied, we divide each side by what x is being multiplied by, right? But we don't want to divide by a fraction. What do we do instead of dividing by a fraction? Multiply by the reciprocal. There you go. So we could multiply each side through by negative 5/6, right? No. The reciprocal of a negative number is negative. Yeah, it's negative. Yeah, we're just going to flip this thing around. And so that cancels the fractions on the right side. I just get x. What do I get on the left side? I just multiply straight across, right? I'm going to get negative times negative is positive 10 over 6, which reduces to 5/3. Okay, and that's all I need to graph this thing, isn't it? Right, I've got a Y-intercept at 2. I got an X-intercept. What did I do wrong here? I graphed those backwards, didn't I?
Good.
You gotta fix it on your notes here. Right? This should have been, I said x equal to 0, right? Isn't that what I did up here? I said x equal to 0, and I got a y value of 2, which is what I graphed. And down here we set y equal to 0, and we got an x value of 5/3. What's 5/3 as a mixed number? 1 and what?
1 and 1, 1, 1.
Yeah, 3 goes into 5 how many times? How many left over? So 1 and 2/3. So we're going to go on the x-axis, we go over 1 and 2/3, and there's my 2 points. All I do is connect and extend, right?
Yeah.
He's speaking on your head.
Okay, there we go. Hang on to those e-tickets. We'll finish them up like... Oh, okay, so if you finished it, you turn it in, that's fine. If you didn't finish them, don't sweat it. I'll collect them later. My goal this week was to give you an opportunity to do a retake, right? Let's do that tomorrow.
Yeah.
That sound good? We'll do a combination of work day, retake day tomorrow. Okay? Yes. Awesome. Thank you.